Hello, this is Mr. Miller. Welcome to video 1L about rotations. We're almost at the end of this big unit. We've talked about a lot of things. There's only one topic after this. All right, let's go ahead and get started. First thing we want to talk about is how to find the angle of rotation. Okay, so here we have a triangle ABC that's been rotated to form A prime, B prime, C prime. The question is, what angle has it been rotated through? Well, to do this, you can find this by finding two matching points. I'm going to use B and B prime. And if you look over here, I've kind of drawn in what I'm going to do. I'm going to draw a line from P to B, and I'm going to draw a line from P to B prime. P is the point of rotation that was rotated about. And then I'm going to measure this angle. So all we have to do is draw a line from the point of rotation to two matching points and measure that angle. If you measure this angle, I believe this was 70 degrees. Actually, I think it was 75 degrees. Okay? And it was counterclockwise because it went opposite the direction of the clock. Now, if I had used points A and A prime, it would have worked out being the same thing. I would have got the same angle. Or if I had drawn a line from P to C and P to C prime, same angle. All the points rotated through the same angle. All right, let's take another example of this. I have kind of a quadrilateral this time. And, well, I'm going to select two matching points. So this time, I selected point A. So here's point A in the original figure. Here's point A prime in the rotated figure. And I drew a line from P to A and P to A prime, and it's shown here. So again, this is a bigger angle of rotation, but we could just use a protractor and measure that angle. And this time, it was a lot bigger. It was an obtuse angle. It was 140 degrees. And again, it doesn't matter which points I selected. I could have used B and B prime or C and C prime. If I measured the angle going to those points, it would be 140. All right, now, I want to try to make sense of the rule for a 90-degree clockwise rotation. The rule is a little bit odd, but if you look at what's going on with the original points and the new points, we can see why the rule is the way it is. So this black triangle is the original figure, and it's been rotated 90 degrees counterclockwise, okay, to form the red triangle, A prime, B prime, C prime. I made a little table here comparing the points. So I listed point A's coordinates and A prime's coordinates, B and B prime, C and C prime. So I kind of want to look and see what's going on with the coordinates as we go from the original to the new. Well, I'm going to look at the last one. C had coordinates 3, 1, and C prime has coordinates -1, 3. This kind of gives me an idea for a rule. So when we write a rule, we write it like this. We tell what happens to a point xy. So xy, what happens to it? How does it become the new point? Well, I see here this -1 is the opposite of the old y coordinate. That's how we get the first point, or the first coordinate of the rotated point. And if I look, this 3 right here, that came from the x coordinate. So when we have a 90 degrees rotation, there's kind of a switching of the coordinates, and we take the opposite of the first one. Let's check this out. So where did this -4 come from? It's the opposite of the old y coordinate here. So -y would be -4. Where did this 2 come from? It's the old x coordinate. This works here too. This is -y. Y was 1 in the original point. And this is x. So here's the rule for 90-degree rotation. The first coordinate is the opposite of the old y value. The second coordinate is the old x coordinate. All right, let's take a look at a 180-degree rotation about the origin. All right, now this pattern is a little simpler to see, but I want to see where this rule comes from. Okay, so again, the original image was the black one. We have triangle RQS. And the new one is R prime, Q prime, S prime. And these are the original and the new coordinates. That shouldn't say -q right there. Sorry, that should say Q prime, not -q. I'm sorry, it should just say Q. So, wow, what a mess. So just Q is -2, -3, and Q prime is 2, 3. And then S is -5, -3, that's over here. And the new S is 5, 3. Now, if I look carefully at what's going on in the coordinates, they're just changing signs. The old X was -5. The new X is the opposite of that, +5. The old Y was -3. The new Y is the opposite of that. So we could write a rule this way. We could say, whatever point we start off with, x, y, this is what it becomes. The new first coordinate is the opposite of the old x. The new y coordinate is the opposite of the old y. Well, that's not so bad. It's a lot easier than one before where we had kind of switching going on. We just changed the signs. So if the old x is -2, the new x is 2. If the old x is old y is -3, the new y is 3. Same thing here. Old x is 0. The new one is -0, which is 0. The old y was -1. The new y is 1. Okay, so if you kind of look at the numbers of what's going on between the original and the new, we can kind of understand what the rule says. All right, we're going to do 2 quick examples where we apply a rule. Actually, I have the answer right here. We're going to rotate this figure 90 degrees clockwise. There's the rule we came up with. We should end up with this. So I'm going to explain where this red figure came from. Okay, well, I like taking a look at one point at a time. So let me see where I got some space to work here. I'll work up here. So M, I'll start with M. I don't know why I just picked it. M, the coordinates of M are -3 and 5. All right, here's how we calculate the coordinates of M prime. We take the opposite of the old y value. The opposite of 5 is -5. And then we take the second coordinate is the old x coordinate. So the second coordinate is the old x, -3. All right, so M prime is going to be -5, -3, which is right there. All right, let's find L. The old coordinates of L are -2, 1. Okay, let's find L prime. The first coordinate is the opposite of y. The opposite of 1 is -1. The new second coordinate is just the x coordinate. Okay, so really I'm just plugging these numbers into the whatever formula is there. -1, -2. This is -1. Here's -2. So this would be L prime. And it doesn't want to stay there. There we go. And let me find the last one, N. The original coordinates of N are -4, 1. So N prime, if you like it this way, we kind of switch them and take the opposite. So if we switch them, this would be 1, but we take the opposite. It's -1, and this would be -4. Or, if you want, this first coordinate is the opposite of y. Opposite of 1 is -1. Second coordinate is x. So M prime, -1, -4, is going to be here. And if you connect them, you get exactly this. So we explain where that came from. All right, you've been very good and very patient. We've got one more example here. And actually, this is a little easier one to do. 180 degrees, I like them. They're quick. So we just take the opposite of the coordinates. Okay, so again, I have the answer right here. So we're going to see how we get it. All right, let's start. T is at 1, 4. And for 180 degree rotation, the first coordinate is the opposite of x, -1. Second coordinate is the opposite of y, -4. I love it. S is 2, 1. Okay, we just take the opposite of the coordinates, so that becomes -2, -1. And what's left? We got U. U is 4, 1. Just take the opposites. U prime is -4, -1. So if I plot them, T prime is -1, -4. That's down there. T prime. S prime is -2, -1. Right there. And U prime is -4, -1. Right here. And I found the corners. It's kind of hard for me to do with my pen, but if you connected them, you would end up exactly with that. Are we good or what? All right. Now, time for your turn. You got one to do. So, here's a figure here, triangle PQR. And I want you to find the rotation by 90 degrees counterclockwise. Here's the rule again right here. So, remember the opposite of y and x. I want you to list the new coordinates, P prime, Q prime, and R prime. Then make a sketch of the figure and the rotated figure so we can see what it looks like. It's going to go left, so it's going to end up over here someplace. All right, best of luck. See you next time.